Hello everyone, I'm Shivam Pasari and welcome to ASIN Academy. Now as you can see from the title of this video, we will discuss Fermat's little theorem in this video. So without further ado, let's begin with our topic. Now basically this theorem is used for calculating the remainders Now questions based on Fermat's little theorem has come in many competitive exams and even in many maths olympiads. So let's find out what is Fermat's little theorem and how it is used to solve the questions. So according to the Fermat's little theorem, when a to the power p minus 1 is divided by p, the remainder obtained is 1, and over here p is a prime number and a and p are coprime to each other. So before going back to the theorem, let me first explain to you what is prime and coprime numbers. So a number is called a prime number if it is divisible by 1 and itself. So for example, 7 is a prime number because it is divisible only by 1 and the number 7 itself. 13 is a prime number because it is divisible by 1 and 13 itself. Now two numbers are called as coprime when there is no common factor between the two numbers except the number 1. So let's take an example for coprime numbers. The number 2 and the number 3 are coprime to each other. This is because they have no other common factor except the number 1. You can also say that 3 and 7 are coprime to each other because they have no other common factor other than the number 1. I hope that you are clear with the concepts of prime and coprime numbers, and if you still have any doubt, then you can check my video about prime numbers where I have explained these concepts in detail. So going back to the theorem, if a number is of the form a raised to p minus 1 and when it is divided by p, the remainder is always 1, where p is a prime number and a and p are coprime to each other. So let's solve some few basic examples so that your concept on this topic will be more clear. So let's solve our first question. So for our first question, we have to find when 2 raised to the power 130 is divided by the number 7, what is the remainder? So the solution for this question is as follows. Now I can see that 7 is a prime number, so I can apply the Fermat's little theorem over here. Now over here my p is equal to 7 and a is equal to 2. Now 7 and 2 are coprime to each other, so it is sure that I can apply Fermat's little theorem over here. Now over here you can see that if p equal to 7, then p minus 1 should be 6. So instead of writing 2 raised to the power 130, I can write it as 2 raised to the power 6 whole to the power 21 into 2 raised to the power 4. So over here if you'll multiply 6 and 21, you will get 126, and if you'll add 4, you will get 130. So I can represent 130 in this form. So if I use Fermat's little theorem for the first case, then 2 raised to the power 6 whole to the power 21 divided by 7 will give me a remainder of 1. So I will be left with 2 raised to the power 4, and I have to find the remainder when it is divided by 7. So 2 raised to the power 4 is equal to 16, and when 16 is divided by 7, the remainder is 2. So my final answer is 2. Let's solve a very similar question. So suppose you have to find the remainder when 2 raised to the power 130 is divided by the number 11. So first I will check that whether I can apply the Fermat's little theorem. The base is 11, which is a prime number, and 2 and 11 are coprime to each other. Now over here I can see that my p is equal to 11, so p minus 1 is equal to 10. So the number 2 raised to the power 130 can be written as 2 to the power 10 whole to the power 13, and it is divided by the number 11. So according to the Fermat's theorem, the remainder for this case will be 1, and my final answer is also 1. That was all for this video, and I hope that you understood all the topics covered in this video. And if you have any doubt, then you can post your doubts down in the comment section, or you can send your doubts to us to our channel's official Instagram or Facebook page, and we will surely solve your doubt as soon as possible. Or you can go to the official website of ASIN Academy and you can send your doubts to us from there, and all the links are provided down in the description. And if you did like the video, then please hit the like button and subscribe to the channel ASIN Academy.